And welcome to Computer Tech and More. We're going to be doing my revamp series where I redid a whole bunch of my noise testing on all the fans I tested to make my data more consistent and better overall. So I'm going to briefly go over what I changed, and then we're going to get into the old versus new and then all the graphs. So first up, what has changed? Well, it's pretty simple. I now have a very fixed, consistent distance between where the microphone is sitting and where the fan is sitting. So before, I just sort of put the microphone as close to the fan as I could without it interfering. I was very much eyeballing it and just let it run. Now I have a pole that I put in front of the microphone and reach it to essentially the fan, and I let it run that way. I'm also very careful so that my house is at the same noise level for the testing. So if the AC unit turns on, I stop my testing until it turns off again. If my neighbor's AC unit turns on, I stop my testing until it turns off. If someone starts talking in the house, I pause my testing until they stop talking. So in that way, I'm keeping the testing much more consistent to try to get you the absolute best data with my current test methodology. However, how can I improve it? Well, through viewers like you. If you join my Patreon page, I'd be able to buy a better microphone, build myself a little sound chamber, and well, just overall everything and anything to make the actually testing better. Also looking at upgrading my instrumentation for getting airspeed measurements, as well as upgrading my case simulation testing box. All right, now that I've finished talking about all that stuff, let's get right into the graphs and the data. All right, first up is what has changed between the old testing methodology and the new testing methodology. So original is on the right side, new is on the left side. And originally the Iceberg Extra Thermal IceGale was 140, was ranked 13th, now it's ranked 10th, so relatively speaking, it's able to push more air for the same noise value. The new decibel reading for my noise normalized testing is 12 decibels, and that's rated off of the A12X25, running at approximately 1,100 to 1,200 RPM. I just found that to be a particularly good value for that fan to push a solid amount of air while being almost completely silent. So on this graph, you can see the RPM the fan was running at, as well as the airspeed measurements. Taking a look at 100% PWM fan signaling through the AirCooler, it hasn't changed because noise is not a major concern here. But you do see the new noise values because, well, it is changed because I'm now measuring the noise differently. Looking at CFM noise normalized, we again have RPM and the CFM value for each of them. Originally it was ranked 6th, and it hasn't changed relative position. It is still ranked 6th overall. However, it is pushing less air for that same position. So it means that it can't actually push as much air for that noise normalized value because it's actually kind of performing worse, relatively speaking, for the new tested methodology. Anyways, at 100%, it's ranked 2nd. And moving on to the case simulation test. It was originally ranked 10th, and now it is ranked 5th. And this is noise normalized values at the 6-inch mark. Moving on to the 11-inch mark. It was originally ranked 11th, and now it's ranked 6th. Again, noise normalized. Moving on to the value. Originally it was ranked 7th, now it's ranked 5th. In value at the 11-inch mark, it was originally ranked 9th, now it's ranked 5th, so it's better value, relatively speaking, compared to other fans than originally. In the cooler testing, noise normalized for its value, originally it was ranked 11th, now it's ranked 7th, so relatively speaking, for the 140 millimeter class fan, it's improved in position for its value. For the CPU cooler at 100%, it's ranked 3rd overall. And for CFM testing, originally it was ranked 4th, and in the new testing methodology, it's ranked 4th again for the noise normalized value. At 100% PWM fan signaling, it is ranked 2nd. All right, let's get into the new graphs and data and actually explain all of this stuff. Okay, so first up in the new testing methodology is the case simulation test. The case simulation test can be taken a look at in a couple different ways. The first way is, what size case are you actually looking at buying? Or what sort of function are these fans going to perform? So for example, the 6-inch mark, that would be for a very compact small form factor case that still has a front to back type airflow. to it. Or something like the Fractal Design Torrents case, where you have the fans at the bottom and they're blowing directly into the GPU. That sort of short throw distance is where you'd be very specifically looking at that 6-inch mark. At the 9-inch mark, you'd be looking at the airspeeds. You'd be looking at the airspeeds at the 9-inch mark for compact towers, front to back airflow, and you want that to be as high as possible. If you're looking at mid-tower cases, something like the Meshify 2C, Meshify C or 2, I don't remember all the naming, or something like the Corsair 550D, basically just a standard BOG mid-tower case, you'd be looking at the 11-inch mark. And if you're looking at a full tower or large case, something like the Fractal Design Torrent, you'd be looking at this 14.5-inch mark. So, what else does this data show us? It shows us how good the fan is at blowing air through a case. So the most perfect fan in the world in an ideal scenario would be a perfectly flat line. At whatever airspeed the air came out of the fan would maintain that airspeed from front to back of the case. But we don't live in an ideal world. There is air inside the case that the fan has to push out of its way, and that of course slows down the air that the fan is pushing. So what are we actually looking for? Well, you want the airdrop to be as slow as possible and as linear as possible. Or not exactly linear, but something where it kind of drops off only steeply at the end. You don't want it to be steep right at the beginning and then level off because it basically zero airspeed throughout the rest of the case. You don't want that. So you want the airspeed to maintain as high as air velocity as possible for the majority of the case, especially for the distances that you are specific. That is basically just how I would take a look at this data, and the data points on here are for 20, 40, 60, 80, and 100% RPMs. So you can see that the IceGale Iceberg Extra 140 already starts off with a fairly high initial RPM of 1,500. So how does it actually perform? You'll notice right away, right here on this graph, that the legend is a 1,151 RPM. I calculated that, meaning the fan doesn't actually spin that slow. I calculated basically the offset distance using like partial fractions basically of where the fan is and how much percentage it needs to drop in order to get to a noise normalized value. So it's not its true value, it is a composite noise normalized value if this fan could actually hit that value. And what we do see when we take a look at that is the fan is a little bit underperforming my control fan, which is 3 parts A12X25 to 1 part A14. Two fans I can consider to be particularly good in their respective categories. So what does that mean? Well, it's a little bit underperforming, but in bigger cases it's actually doing a little bit better. But we're not gaining a lot of information, so let's see how the fan does at 100% PWM fan signaling. Well, it blows my control fan just out of the water. The control fan here would be approximately spinning at 1,200 RPM respectively. So again, that's calculated based off of the two fans that I then merged together to create this control fan. Meanwhile, the Iceberg Thermal Extra, the IceGale Extra, is spinning at 2,500 RPM and producing 40 decibels of noise. But how good is this fan compared to others? Well, here's the data. So here is the Iceberg Thermal Extra noise normalized. So you could consider this to be like kind of its true value, and just realize that it actually won't be as quiet as it appears, because this isn't truly noise, it's minimum RPM, it's the calculated minimum RPM, if it was able to achieve that. So it's basically a middle-of-the-pack fan for a given RPM. When we take a look at it, and it actually creates a fairly flat line compared to other fans, and you can see how other ones perform, like the A12X25 actually performs a little bit better than it initially before becoming not as good. So that's the problem with 120 millimeter class fans, is they just are not quite as good at bigger cases. If you have a smaller case, they do just fine, but bigger cases, they tend to drop off in airspeed much more rapidly than 140 millimeter fans. But of course, there are always exceptions to the rule, like the Storm T3. How are things at 100% PWM fan signaling? Well, brute force always wins. And here we see the IceGale Extra just spinning at 2,500 RPM, 40 decibels of noise, and it's kicking some serious butt. The only other fans that beat it are the 3,000 RPM NFA14 at also 40 decibels, and a close contender is the Silent Wings 4 Pro 140 spinning at 2,400 RPM, producing 31 decibels of noise. So it is much quieter for the same RPM, but you are also not getting the same amount of air. And this blue line here is the Tough Fan 14. It's got a noise level of 33 decibels. And if you're looking at a bigger case, it's also not a bad result. Now, the 9-inch mark was, in this next graph, we're looking at the 9-inch mark of airspeed versus decibels. The 9-inch mark was chosen, let's jump back to a couple graphs, because like for the Storm T3, there's a big drop-off between the 6-inch and 9-inch mark. And then some fans will have an even steeper drop-off from 9 to 11. So it means as airspeed gets lower, my anemometer becomes less consistent, being able to give me good readings, which is why I would like to upgrade it through the help of viewers like you. So the 9-inch mark was chosen because it's the last point that I can get good consistent readings. Fans that lose a lot of performance because they shoot air in every direction still produce enough airflow that I can get good readings, while fans that create a good concentrated airflow are still really nicely concentrated and going to give me basically the best results and show what they've got. So how does the Iceberg Thermal Extra do? Well, it starts off at over 15 decibels by my readings. So once again, these are using my microphone through my testing methodology. So it isn't quite like true 15 decibels. I don't want to like set expectations, but it's kind of noisy at that level. And you can see how it kind of just is already noisy compared to many other fans. But for its airspeed, it's on the noisy side. It's in the middle of the pack. And as RPM increases, so as airspeed increases, it actually gets more efficient. It becomes one of the top performing fans. The only one that does beat it out is the NFA14 IPC 3000 RPM fan. So if you're looking for a fan that can push a lot of air, this is certainly a very good choice. But if you're looking for one that is silent while doing it, I would look elsewhere. And you can see a number of other fans that are listed on here. The Storm T3, the Silent Wings 4 Pro, what's this green one? The Tough Fan 14, just to give you some good respective comparison marks. Alrighty, next up is airspeed through my CPU cooler, which is the Noctua U12A. And there are two graphs here. The left graph is RPM versus airspeed. It's basically pure blade efficiency. How good is this fan at pushing air through this heatsink? So it's just an efficiency of how RPMs, airspeed, which is best. And better fans are going to be sitting top left, worse fans bottom right. The right graph is, wait for it, noise versus airspeed. So this is how much noise does that fan produce for that airspeed. Again, better fans are going to be top left, worse fans are going to be bottom right. So going back to the first graph, which is RPM versus airspeed, what do we see? Well, initially, it starts off at a very high RPM. It's underperforming my control fan, and then it just kind of blows it away. So its blade design is actually quite good, I would say. It's great at moving air. But when we take a look at the second graph, which is noise for that given airspeed, it's kind of bad, actually. So I know that we topped out the control fan at, its value, which is like 2,200 RPM. But the Iceberg Extra just is very noisy for how much air it moves. But again, it's moving a lot of air, so you can't have a perfect fan. So how does it compare against other fans? Well, again, its calculated noise normalized value gets it into this position. And one other note I want to indicate about this graph, for a key piece of information I'm going to divulge in a second, is like 250 W equals 3. This is 250 watts equals 3 meters per second. So I did a whole series of tests on my CPU cooler, the U12A, for what RPM, so PWM fan signal, gives me an RPM, gives me an airspeed through it. I measure it with an anemometer. So what airspeed through the CPU cooler equates to what wattage my CPU would draw. Note here that my CPU is the 11700K, so there are even slight inconsistencies within that same CPU. So if you're using the same cooler as me and the same CPU as me, the wattages won't quite exactly line up. And if you're using a different CPU, these wattages won't line up either. And if you're using a different cooler than me, the wattages won't line up as well. So how can you use this data? Well, it gives you relative performance. So let's say your original cooler came with this Hurricane 140. At my noise normalized value of 12 decibels, it would be moving 0.7 meters per second of air. Well, if you upgrade to the Iceberg Thermal Extra, IceGale Extra, you'd be now moving 0.9 meters per second of air. So that means you now would have more overhead. Your CPU could draw more wattage, or your CPU is now going to run colder for that given original wattage, depending on what kind of CPU you have. Or you could dial back the RPM on the fan and have it run quieter for the original wattage. So it just gives you a relative starting point. Mind, the Iceberg Extra at noise normalized values is calculated noise normalized if it could get that low, but its actual starting noise normalized value is pretty noisy compared to the other fans. But it just shows you, hey, if I have this and I jump up to this fan, you can see a improvement in performance. So at 100% PWM fan signaling, again, the wattage equals airspeed is indicated on it. We see that the Iceberg Thermal Extra is a very good top performer. It's spinning at 2,500 RPM, and for fans that are spinning that fast, it is the best, but you're also paying for it in its noise value. It is a very, very noisy fan. The Silence 4 Pro is ranked third, and you can see how other fans rank here as well. Now, how does it perform through the cooler? So airspeed versus decibels. Well, here it's actually towards the bottom of the pack overall. As a note, these fans that have these joggles off to the side, that's where the fan hit a harmonic frequency, either in the testing apparatus or within the fan itself. I'd need to do further testing to determine which it is. But either way, in my testing, I hit a harmonic frequency, and so the fan got very noisy all of a sudden. And then when you go past it, it quiets down again, where it should be, you should be able to just connect those lines, basically. Anyways, so the IceGale Extra is actually pretty noisy for how much air it's moving. Mind, it gains efficiency as airspeed goes up, as RPM goes up, but overall I find it noisy for its performance value. In the next graphs, we're taking a look at CFM. So CFM is basically a scientific calculation. I don't personally like using CFM, cubic feet per minute in this case, but it's just a volumetric flow rate, because the way you do it is you're blowing air down a tube of some kind, and it's ignoring information like, is the fan good at blowing air in a straight line out the back, or does the air spew off to the sides? If you're blowing air down a tube, all the air is going to be traveling in the same direction, and you're hiding the fact if the fan is not particularly efficient. The fans are going to look a lot closer in performance than they are at given RPMs. So that's why I don't really like the test, and a lot of reviewers who do fan testing just completely don't understand this. I have a background in aerospace engineering and specifically in fluid dynamics, so this is something that I actually fundamentally understand. But if you're looking at doing wind tunnel testing, or actually like I don't know, rocket motor analysis or something along those lines, CFM in that airflow through a tube is actually a good way to compare results. So right here we have the test data for CFM for the testing. The way you calculate CFM is you know the airspeed of the air traveling down the tube, and you know the surface area of where the airflow is traveling through it. In this case, it would be like the surface area of a cylinder, so the flat face of it. So using the surface area of that times meters per second, so that's meters squared by meters per second, so that becomes meters cubed per second, and then you can convert that to cubic feet per minute, and there you go, you got your volumetric flow rate. So how does it compare against my control? Well, here the iceberg or IceGale Extra is actually doing pretty well. Again, at lower RPMs, it's relatively speaking lower RPMs. It's not as good, but as RPM increases, it gains a lot of efficiency. It really shows in this graph. In terms of the noise value, though, well, here it actually does pretty well, surprisingly. It is outperforming my control fan in noise versus CFM. So it's a very different result than what we saw with through the CPU cooler. Now, how does it compare against other fans? Well, at its quasi-noise normalized value, it's ranked towards the top. So it's overall doing kind of well here overall. At 100% PWM fan signaling, it again is doing really, really quite well. And this kind of demonstrates my point about like RPM, airspeed, and just ignoring results. These fans were the A14 and the Iceberg Extra were much farther separated in all the other graphs until we hit the CFM one, which kind of iterates my point that it hides results if you're only looking at CFM. You need to take a full encompassing view of these fans to get all the information you can get. Now, how does it do in CFM versus decibels? Well, I'd call it actually the best fan, arguably the best fan. It just is kind of outperforming all the other ones here. It doesn't have the highest result, but until that point where it stops in performance, it's basically doing the best, and it's following trend lines for many other fans. Alrighty, now that we've finished all the other sections, let's take a look at the value proposition. So value proposition is a very simple calculation. It's airspeed or volumetric flow rate divided by dollars. And the value is based off of the retail pricing, so standard pricing for the fan. If the fan has gone on sale or something like that, you could expect the value proposition of it for it to go up. In the same way, if its regular price has gone up, its value proposition would go down. So because it's so easy to calculate, you already have the numbers for it from the previous sections of these graphs that you can easily recalculate it for any of these fans that you're interested in to pick out the best one at its normal retail price. This also includes retail pricing. So like the Storm T3 comes in a triple pack. So that means I divide the cost of the triple pack by 3 and then divide that by dollars. So that's why some of these have really good values. So now that that explanation is out of the way, on the left side we have noise normalized results, and on the right side we have 100% PWM fan signaling results. Well, the IceGale Extra is kind of towards the top in noise normalized values, but not exactly at the top. There are just other fans that are much better value. But if you're looking at only 140 millimeter class fans, it's okay. When you're taking a look at things at 100% PWM fan signaling, well, here it's one of the best. It's not the best, but it's certainly one of the best. And this brings me to a point that I just forgot to mention. How should you use this data? Well, if you're on an ultra tight budget where money is everything and you're trying to get the absolute best bang for your buck, that's where you'd use these graphs 100% specifically. You would only pick out the best fans, the highest rated value. So in this case, the TLG12. If you only want 140 millimeter ones, you'd actually probably looking at the Storm T3. If your budget isn't super grossly tight and you've got some wiggle room, you either want higher performance fans or you want less quieter fans or you want some RGB. You can use this data to pick out which fans have good enough value and use the previous data to basically go which ones have the performance characteristics that I actually want and pick out the best ones that fit the value proposition that you like. And if you've got unlimited budget, well, move on to the next section, silly. You don't need to look at value unless you want to justify spending $40 on a fan. But you can see that the IceGale Extra here just is a higher end value because it's able to push so much air, but it's a little bit on the expensive side, which is why it doesn't quite reach the top end as some of the other fans. I did forget to mention that it is a $24 fan, so that's why it's got the positioning it is. Several cheaper fans are like $6, so can't have everything. Next, we're taking a look at the 11-inch mark. So how does the IceGale Extra do on these graphs? Well, it's kind of middle of the road for actually it's upper middle for 140 millimeter class fans, but when we take 120s into account, it's not that great value. And when you're taking a look at it at 100% PWM fan signaling, well, it's actually doing really quite well here. The Storm T3 has completely dropped out. It's not particularly good at blowing air in a concentrated airflow, but its value is actually okay in the 140 millimeter class category. But something like the P14 from Arctic is actually the top performer here in the 140 millimeter class. But all those are blown away by like the TLG12 and the P12 Max. They're just so much better value fans for airflow at the 11-inch mark. Now, all of that said, how does it do with airflow through the CPU cooler? Well, here it's again kind of upper average in its category of 140 millimeter class fans, if I can talk properly, but it's just blown away by the better fans, better value fans in the 120 millimeter class. And the same holds true at 100% PWM fan signaling. It just can't quite overcome its initial cost. And lastly, taking a look at CFM results, here is where the fan actually shines. So the Storm T3 is our top performer overall in CFM, outperforming the TLG12 and everything else. But this reiterates my point about why you need to take a look at the other pieces of information, where CFM calculations hide all these other details about a fan. So then we take a look at it at 100% PWM fan signaling, and it's second here. And it's very close in performance here to the better 120 millimeter class fans. So what do I think about this fan? Well, if we're taking a look at the value proposition, it's okay, particularly if you plan on using this fan at higher RPMs. But overall, I'm going to say no, and there are a couple reasons for that. One is I had major issues getting the IceGale Extra thermal fans to work outside of BIOS on my computer. And I cover this in my original review of the video, or of this fan, where I just couldn't get the fans to run outside my BIOS. They draw a particularly high amperage, for one, and they would just shut off when I left BIOS. I don't know why. It could be because I used 3-4 extenders just to connect my fan to the testing apparatus, but every other fan runs just fine. It could be something about these fans not running properly. The other thing I noticed about these fans is that they tend to rev up and rev down while trying to hold a consistent PWM fan signal. They'll just go woo, woo, woo. So if it was me, I wouldn't buy them, but that's just my opinion. If you want to take the risk on it, think they look pretty cool. They definitely would be good performance. Just know that I couldn't get them to work as originally intended. All right, in wrapping up this video, I always like to show off my raw data, and here's the IceGale Ice Thermal Extra. And if you want to use this raw data for your own personal purposes, like making your own Excel charts, data, that sort of thing, for just your own reference points, it's something I've done, you're welcome to go ahead and copy this down and use it for that. However, if you want to use it in any sort of publication, written, journal, video, just any publication that you're going to publish out there, I do ask that you reference me and my videos because I'm the one who generated this data. It generally takes me about 1.5 to 2 hours to do all of the different types of testing per fan, and I've tested over 50 fans. And then it takes many more hours to update graphs, charts, organizing the data in the Excel, graphs, templates, and that sort of thing, as well as time to create the PowerPoint presentation used for making the video and then recording the video itself. So please just reference me if you're going to use it. Anyways, I do appreciate you watching this video. Please check out my Patreon page, and I hope to see you next time here on Computer Tech and More.